Good day, viewers. In this virtual class, we're going to find the derivative for logarithmic functions. So essentially, we're going to establish how to find the derivative of a logarithmic function. For example, we have y is equals to log base a x. Here we're going to establish the formula for it from the first principle with the application of limits. Now, if you recall, this limit, if I have limit of p as p tends to infinity of this function here, 1 plus 1 over p raised to power p, this limit here, as it tends to infinity, for applying logarithm here, our value will be e, which is approximately 2.718. Okay, so we're going to use this fact, to establish the logarithmic derivative of logarithmic functions. Now, if we have y is equals to log x to base a, here from first principle, here y will become y plus delta y. This will become log a, log base a x plus delta x. So that means in place of s, we're replacing it with s plus delta x. Okay, and here we have delta y is equal to y is moving to the right hand side, become log to base a x plus delta x minus y, but y is equals to log x to base a. So here we say this is delta y is equals to log x plus delta x to base a minus log x to base a. Okay, from the law of logarithm, here we have a minus. In minus, what we do, we divide. So here we assume we take the log as a common log. Now we have delta y is equals to log to base a. Here will be x plus delta x all over x. Okay. Here, this term in the bracket here, x plus delta x over s, can be written as x over x plus delta x over x, because they mean the same thing. So here this will become 1 plus delta x over x. So we replace this, that's delta y is equals to log base a. Here we have 1 plus delta x all over x. We close our brackets. Okay, and we know what we are looking for. We are looking for the y, the x. Okay, we are looking for the y, the x. Now, if we come here, if we say divide both sides by the y, the x, that means by delta x. So here will be divide by delta x. And if that happens, so here we have delta y over delta x is equal to 1 over delta x, okay, log, if this one is times 1 over delta x, that's the expression here, log base a 1 plus delta x over x. Okay, this expression here, 1 over delta s, we can also write it as 1 over x times x over delta x. So x will cancel x, and we still have the same result here. So we are going to replace 1 over delta s with this expression here. So here we come for that, and we say this is delta y over delta x is equals to 1 over x times x over delta x. Okay, log to base a 1 plus delta x over x. Here I'll close our bracket. Here we have a x over delta x, but we want to make this one so that this delta x over x become s over delta x. Okay, so that it will be of this form. Okay, how do we do that? It simply means that if we say 1 divide delta x over x, it becomes 1 times x over delta x. So what we'll do here, we'll do some transformation on this bracket here, so that our delta y over delta x is equals to 1 over x times x over delta x, the open bracket. Okay, I'll have a log to base a here. Here will become 1 plus 1 over x over delta x, because if we say 1 divided by this expression, it's definitely going to give us this 1 divide x, 1 divide by x delta x is going to definitely give us this expression. So it will turn. All right, so here this x over delta x, we'll move it applying the law of logarithm to just this, so that we will have this expression 1 plus 1 all over p, something similar to that. So we have delta y over delta x is equals to 1 over x log a open bracket 1 plus 1 all over x over delta x, we'll close our bracket, raised to power x over delta x. Okay, by letting x over delta x is equals to p, we see that this become 1 over x log a open bracket 1 plus here 1 over p raised to power p. But we said that as this limit, as p tend to infinity, the value the value of as p continued to increase, the value of this expression we stabilize to be what? E, which is the Euler's number. Okay, so it simply means that as p tend to infinity, then that is delta x, delta s also tend to 0. Okay, so that our delta y over delta x becomes delta s become the y, the x, and the whole of this expression become 1 over x log e base a. So this is the derivative of, if you are differentiating a logarithmic function, the y dx is 1 all over x log e to base a. So this is the formula for logarithmic function. So we apply these limits, in the process of its derivation. So once you are given a logarithmic equation, this is the approach, this is the formula, 1 over x log e to base a. Okay, please, all you help me do, I need you to help me subscribe, also help me to share this piece of information to other platform, so that when next this kind of thing comes up on my channel, you can easily get a notification. You can as well hit the notification button. Thank you very much. Have a nice time.